are given the function y equals x cubed minus 2x squared plus 4x over x squared minus 4. This is a rational function, and we're going to sketch its graph using the standard curve sketching process. That includes analyzing the domain, intercepts, asymptotes, the derivative, and end behavior. First, the domain. The function is undefined wherever the denominator is 0. Setting x squared minus 4 equals 0. We get x equals -2 and x equals +2. So the domain is all real numbers, except x equals -2 and x equals 2. Next, we simplify the function using polynomial division. If we divide the numerator by the denominator, we get y equals x minus 2 plus 8 times the quantity x minus 1 over x squared minus 4. This simplified form will make it easier to differentiate and analyze the graph. Now, the intercepts. Let's find the y-intercept by plugging in x equals 0. F of 0 equals 0, so the graph passes through the origin. Next, the asymptotes. There are vertical asymptotes where the denominator equals 0. That happens at x equals -2 and x equals 2. Now for the slant asymptote. From the simplified form, we see that as x becomes very large or very small, the fraction gets closer to 0. So the function approaches y equals x minus 2. That is the slant asymptote. Now we'll find the derivative to analyze the slope of the graph. We differentiate the simplified form y equals x minus 2 plus 8 times x minus 1 over x squared minus 4. The derivative of x minus 2 is 1. Now, applying the quotient rule to the fraction, we get y prime equals 1 minus 8x squared minus 16x plus 32 all over x squared minus 4 squared. Let's consider the behavior of this derivative. The denominator is always positive, except at x equals -2 and x equals 2, where the function is undefined. The numerator, which is 8x squared minus 16x plus 32, is also always positive. So the entire fraction is positive, and we are subtracting it from 1. That means the derivative is always less than 1. As x approaches -2 or +2, the denominator becomes very small, so the derivative drops toward -infinity. As x approaches positive or negative infinity, the derivative approaches 1 from below. This tells us that the graph increases overall, but the slope is never steep. It also decreases sharply near the vertical asymptotes. Let's evaluate a few key values of the derivative. At x equals 0, the numerator becomes 32, and the denominator becomes 16. So y prime is 1 minus 32 over 16, which equals -1. At x equals 1, the numerator is 8 minus 16 plus 32, which is 24. The denominator is 1 minus 4 squared, which is 9. So y prime is 1 minus 24 over 9, or -15 over 9. At x equals -1, the numerator becomes 8 plus 16 plus 32, which is 56. The denominator is again 9. So y prime is 1 minus 56 over 9, which is -47 over 9. These values, -1, -15/9, and -47/9, show that the derivative is negative throughout this region. And as x approaches positive or -2, y prime approaches -infinity. Let's analyze the end behavior. Looking at the simplified form as x approaches infinity, the fraction tends to 0, so y approaches x minus 2. To determine the direction it approaches from, try plugging in a large positive number, like 100. The extra term is positive, so y is slightly above the line. Y equals x minus 2. As x goes to positive infinity, the graph approaches the slant asymptote from above. Now try a large negative number, like -100. This time, the extra term is negative, so the graph approaches the slant asymptote from below as x goes to -infinity. As x approaches 2 from the right, the derivative tends to -infinity. This means the original function increases without bound. Along the vertical line, x equals 2. Similarly, as x approaches -2 from the left, the function decreases without bound along the line x equals -2. Between -2 and 2, prime starts at -infinity, then increases through -47/9, -15/9, and -1 before dropping back down toward -infinity. But since y prime stays negative throughout, the original function keeps decreasing the entire time. To summarize, the domain is all real numbers, except x equals -2 and x equals 2. The graph passes through the origin. There are vertical asymptotes at x equals -2 and x equals 2. The slant asymptote is y equals x minus 2. The derivative is always less than 1, and it drops sharply near the vertical asymptotes. As x approaches infinity, the graph approaches the slant line from above. As x approaches -infinity, it approaches from below. That completes our analysis and curve sketching of the function. Y equals x cubed minus 2x squared plus 4x over x squared minus 4.